So I'm going to ask Renee and Patrick to come up. We're going to try this as a hybrid panel. We have 2 people online and 2 people here. Hi, Renee. It's good to see you. And Renee, if you noted, 2 generations of her work ago was actually at the first Nike GC3 Roundtable. Sorry. Okay. Well, you'll say it later. Okay. Anyway. So we started our conversation here earlier talking about Bill raised the need for safer chemistry. We know the challenge here is 96% of chemistry or some big number like that is organic chemistry, and organic chemistry requires carbon. So we talk about decarbonization, but actually you can't decarbonize the chemical sector because it's based on carbon backbones. So it's really about defossilization, which is the term that's being used in Europe now. And if we start thinking about, right, and we'll talk about in this panel, we don't want virgin fossil fuels. So we want to move away from what we might call petrochemicals, and we'll talk about that. But where are we going to get the carbon from? We need carbon to make chemistry. But at the same time, as we've heard about this, and that's where the push is coming often for Scope 3 emissions, for those, why Chad sort of focused on carbons, because that's where the push is coming from their investors, is they've made commitments to decarbonize, to defossilize. So how do we, though, not forget that just changing carbon backbones may not be enough? In working with groups working on defossilization in Europe, they really are only focused on renewable sources of carbon, different sources of carbon. And you ask the question, well, what about the toxicity? And they're like, that's too much for us to deal with. We got to deal with the carbon. And I understand, if you think about the R&D cycles, and some of the companies at our roundtable in Europe talked about this, like, we can make the same stuff with renewable carbon very quickly, within 3 to 5 years. Making totally new molecules is 10 to 15 years. Shouldn't we be doing, given the existential threat of climate change, shouldn't we be doing what we need to do to address climate change? And frankly, I've had this with conversation with climate gurus. Well, we need to do this existential threat. Toxicity, you can deal with that later on. Well, if you're in a community that's been impacted in Louisiana and Los Angeles, as Bill was saying, that may not be, right, it isn't the carbon that matters, right? Well, you're having increased climate change, so carbon does matter, increased accidents due to flooding and hurricanes. It does matter, but what's mattering right now is the communities are contaminated. They have toxic risks. How are we going to deal with those? So what we want to talk about here is, how do we marry those two? How do we, if we're making massive investments to defossilize our economy, how do we make those massive investments so that we address multiple challenges at the same time? So I was with one major company, and I won't name that company, that was very excited about their bio-based benzene. And I was like, I get it. I'm a health scientist. I get it, but, and pretty much most organic chemistry is, is backward integrated to benzene, toluene, xylene, ethylene, propylene, and a bunch of other hydrocarbons. I get it. You can make a super green molecule, but it's going to start back at a backbone chemical that might be problematic. So how do we think about broadly combining these forces to make better? Because a company like Renee's company doesn't only worry about carbon, they're worrying about toxicity. So how do we marry the two more effectively to really advance multiple goals that address climate change, community health, circularity? And that's what this panel is trying to get at, and challenge our community to try and marry those together. Because in the end, we want to have functional chemistry that works, that's safe, effective, lower carbon, and we may not get there unless we really put the effort into thinking about multi-problem solutions. So with that, I want to introduce our panel. We have an amazing panel. From London, we have Richard Wielechowski from Planet Tracker. From Los Angeles, we have Marta Arguello, who is one of my longest standing mentors in the environmental justice movement. Here on stage we have Patrick Foley, who's the CEO of P2 Sciences, a green chemistry early stage company, and Renee Hackenmiller-Paradis, who I've known in many iterations of her career, who's now the head of chemistry innovation at Lululemon. So we're going to start with short overview presentations, and then we'll have a lot of time for discussion at your tables about how do we marry the two, how do we address multiple challenges and not lock into just a little less bad, but really think about really game-changing innovation. So I think with that, we're going to start with Richard. So Richard, thank you so much for joining us online, and appreciate your joining us this morning, or this afternoon.
This evening even.
This evening. Oh yeah,
Thanks very much for having me.
That's right, it is evening in London.
Thanks very much for having me. Hopefully you can see my slides on your screen. Delighted to be here. Yes, I'm Richard Wielechowski. I am a senior research analyst at Planet Tracker. Planet Tracker, I'll just introduce us briefly, is a non-profit sustainable finance think tank. So we produce research aimed at investors and corporates focusing on nature-related risks and opportunities. Our team's a mix of people coming from both a sustainability background, probably having worked for NGOs or consultancies, and those who come from a financial background with experience at large asset managers and other financial institutions. And we think that provides us what we see as a unique foothold in both camps and allows us to sort of act as a bridge and bring both a financial lens and a sustainability lens to a lot of the challenges that we face, and indeed the one that we're going to talk about on this panel. We have a range of different areas that we're focused on. I won't spend any time going into this, just to say that chemicals is obviously a hugely important one in pet chem, plastics, across both toxins, plastic pollution, greenhouse gas. So it cuts across a lot of the themes that we're talking about. And we produce research blogs. We engage and meet with investors. We do teach-ins, etc., to try and help them to understand and include sustainability as a key part of their investment strategy. So given that, I'm really going to focus today on the sort of the financial implications, the reason that it's a challenge, and what are the challenges and roadblocks to getting finance behind sustainable, cleaner chemistry. So just to step back, I think one of the things we need to acknowledge about the challenge of decarbonising, and obviously, yes, I agree, defossilizing chemicals is it's not a quick project. It's something that is going to take a number of years and require a range of different approaches and technologies. It's also likely to require significant investment. That might be in R&D. We were just talking about and hearing about, the idea of alternative chemistry. That's maybe decades away, or it might be new feedstocks or new processes. It might need capital expenditure to build new plants, new factories, or retrofit the facilities that we already have on the ground. But what that all means is that finance is really critical for transitioning, and it also means finance can play a huge role in shaping and supporting that journey. And if we want finance to support certain decisions, then we have to make sure that they understand the implications of the decisions that they're making. So at a high level, what do we hear from investors are the challenges when they're sort of talking about sustainable chemistry? Well, firstly, brutally, it's a complex area and they can get buried in the detail. We hear from investors that they often find it difficult to critique a corporate strategy because they're not chemical experts. When they go into a meeting and they sit down opposite, a PhD of chemistry, a chemical engineer, it's quite hard for them to say, no, that solution's not right, because they don't feel they have the expertise. Secondly, it's both long-term and short-term changes that are required. Some of these changes will be faster than others, and investors may find it hard to assess an overall decarbonisation strategy, an overall transition strategy, which has a multi-decade time horizon, when their own investment horizons may be a year. They may make them loath to support investment in those longer-term solutions. The fact there's not one answer makes it complicated. They're not experts. If there's not an industry-wide one-size-fits-all answer, how do you know who's leading and who's lagging, who's investing in the right solutions and who's investing in the false solutions? And of course, trade-offs in any choice. Do investors, for instance, support biofeedstocks over oil and gas? What about the potential impact on food supplies? Are they going to support, investment in biofeedstocks only to have NGOs turn around and say you're taking food off the plates of people who are hungry in the third world, for instance? So overall, we find helping investors with what questions they should ask, why they should ask them, and what answers they should look for is a hugely important part of moving the conversation forward. Now, when we're talking to them, what we try and talk about is opportunity and risks. And just to talk about some of the risks that we spend a lot of thought process on is firstly false solutions. Is, for instance, carbon capture going to save the world, or is it pie in the sky? Are carbon credits a legitimate use of corporate cash, or is it something that should be avoided or only used in very limited circumstances? Is there a risk of stranded assets? Will assets, factories that are not set up for a new chemistry, for a decarbonized chemistry, end up being put out of business? What is the timeline for that to happen? Litigation risk. Will a failure to act store up litigation risk down the road for corporates and their investors? And finally, they all worry to some extent about the risk of being a first mover. It's a complicated area. Is regulation already there? Is the risk that if you push your corporate that you invest in to make a big change, to be a first mover, they end up spending a lot of money, making a lot of mistakes, and actually it's the competitors who get to learn from those mistakes and naturally benefit. So bringing it all together and to plug some of our work, we find it's been very useful for investors to kind of analyze corporate transitions, to look at exactly what they're doing, deep dive into the governance, deep dive into the capex that they're putting in place, deep dive into their strategy and say, okay, what are they doing? Is this in line with a 0.15 degrees C future? Is this in line with a more sustainable chemistry? Because all of them will say they are, but it's only when you really get into the nitty gritty that you can really test those assumptions. So with that, I'll wrap up and say thanks for your attention. Please do get in touch if we can be of any help. Always happy to talk on any of these subjects. And with that, I'll hand back to the room. Thanks very much.
Thank you so much, Richard. And now we'll pass to Martha online.
Great. Thank you.
And we're sorry not to have you, Martha.
And I'm sorry to be there, not to be there. But since you outed me and my nerd crush on John Warner, I want to give a little background of why and how long we have at Physicians for Social Responsibility. We're a physician membership organization. The Los Angeles chapter is one of the largest in the country. And we worked in many ways differently than what you might have remembered of Physicians for Social Responsibility. We started as an anti-nuclear organization. We're one of the first chapters to take on issues that our physicians were seeing on the ground. So everything from gun violence to environmental health and then climate. We were one of the first chapters to really develop a set of programs around there. And I came on board to actually work on the issue of pesticides and how do we frame the issue of pesticides as a health issue, and really rooting it in who is most impacted in California, and particularly with pesticides. And so that's how our organization began. We're about 20 staff now and are deeply rooted in the environmental justice and health movement, even though we are a physicians organization. Our physicians and nurses and other health professionals, but we really try to do our work from the perspective of the communities on the ground who are most impacted by different industrial practices. And so in 2011, we organized a conference. We thought we were very clever by calling it From Molecules to Movements. And we brought John Warner. And what really moved me about that was we also brought in about 150 high school students who were in a program about how to solve problems in their community. And so most of their training is like, well, they're high school students. They thought, oh, I should be a lawyer, or I should be a doctor, or maybe I should be a police officer if I want to solve problems in our community. And we really reframed that question is, how do you solve the problems of pollution in your communities, and using green chemistry as a lens, which is what we were doing. And so we have been trying to understand how green chemistry can be a tool to actually reduce the harm in communities. If I were to do this conference again now, I would call it From Molecules to Movements, building beyond circularity and moving to a generative economy. And because circularity shouldn't just mean circulating more toxic chemicals into the environment. And so we often talk about our work as to decarbonize, detoxify, and democratize. This was at the core of our work to create the first climate emergency mobilization office. It's at the core of our work, working directly with communities who are living in the shadow of oil drilling to end oil drilling in Los Angeles. Los Angeles has one of the largest urban oil fields. And so those communities understood you're living on the front line of oil and gas production that is then, going off to the refineries and becoming other products that we also deal with. We often talk about our work in the regulatory realm in trying to address the fact that more communities of color, low-income communities live in the shadow of this, is addressing the sins of the past, where we had practices, and think of extractive economies, whether that's mining, oil drilling, water, right? I live in a city where we are based on stealing water and pulling oil out of the ground. And so how do we address those sins of the past, right? The legacy of contamination. And if you think of most regulatory approaches, they kind of grandfather in, and folks should look up what the history of that term, where that term comes from. And so no one is addressing the sins of the past is what we kept seeing, right? Green chemistry is not going to solve that problem. Yet our communities live in those communities, right? So brownfields, Superfund sites, contaminated water and soil, that's the legacy of these sins of the past of unbridled extraction with no accountability. So the current sins, right? Those are the things, that we currently permit because they're an important part of commerce. And what are we doing there to actually address the range of pollution? And we call carbon the co-pollutant, right? No facility just emits carbon. It's myopic. It actually does not solve the problems. It makes wicked problems worse when you only focus on carbon, right? It doesn't address toxicity. It doesn't address legacy, but it also does, it pretends as if you could address these things in a vacuum, and that air pollution somehow is not related to carbon emissions. And then the sins of the future, right? This is where we saw hope for green chemistry in actually addressing how going forward, we do things better. How do we center public health in our conversations about the products of the future? And, that's a carbon capture facility, I believe. And, that to the environmental justice and health community, those solutions are really problematic, and I'll talk more about it in a bit. But we tend to look at things from this whole life cycle. This is a graphic done by the Just Transition Alliance that's looking at the range of impacts. And there are community and environmental justice groups working at every point, right? From consumer, from the waste, from the ocean's point of view. We are all working to stop that harm. And this is what it looks like in the community where I grew up in, right? So that we lived, when I was a little girl in the 60s, the first Toys R Us that opened had a pump jack that was painted like a giraffe. And we would get so excited about going to see the giraffe. And little did we know that it was, we had no idea, and they were ubiquitous growing up in Los Angeles. This is what it looks like from the front lines, whether that's drilling, refineries, waste facilities. We have solid waste incinerators. We have waste to energy facilities. We have biofuels facilities. This is, again, there's a consolidated making of containers, right? And if you look at you can see all the other facilities that are in this Carson neighborhood, and people also live here, right? So people are living where they're making the base ingredients of your products, and they're living where we dispose of them. And in many cases, we are also buying and consuming. I'm going to go through this really fast. Actually, how I first met Joel was when we were working on the precautionary principle. I was new to the environmental field. I come from public health, having worked on some of the first AIDS programs for Latinos, having helped develop some of the first interventions for Latina women around breast cancer. And so I've worked on the health endpoint side and was frustrated with the things that we were telling women on how to prevent breast cancer, and realized, wait, there is a driver of these illnesses that we are ignoring. And so the precautionary principle made sense to me as a person from public health. And now we, as I think of the solutions, I want all of you who are product developers and thinking about this is, how does this stop the harm and how does this repair the harm that's already been done, that we are collectively and individually sometimes responsible for? And then, this is again from public health, stop making the problem worse. And one of the things that I see, and I work on climate policy, I work on toxics policy. I've spent the last 16 years serving on California's Environmental Justice Advisory Committee on climate change. And in 2006, we said it's not a good idea to be using corn and other feedstocks to produce fossil fuel, to produce fuels. And, lo and behold, many researchers are now saying what we said, what the canaries in the coal mine of our community said, this may not be a good idea. And I just want, it may be controversial, but it's the most important thing I might say to this particular group. Stop commodifying carbon. Just stop, please. It's not a panacea to address climate change. And it's not just me saying it. There are researchers, but if you commodify the thing you're trying to get rid of, you know what happens? You don't get rid of it, right? You come up with accounting tricks and other ways to say, oh, well, we're net zero, but you don't get to real zero because it's a commodity and somebody's making money from it. And we know how hard it is to unravel that once you start making money off something, it's really hard to stop. So just again, stop commodifying carbon, because it is our communities, it is environmental justice communities all over the world who are bearing the burden of these practices that commodify carbon. So I'm going to go through these quickly because this is one of the things we do when we're talking to regulators. Stop deciding what's good for us. Stop, and often that's what happens with companies and regulators. They decide, they announce, and then they defend that decision. Environmental justice communities are actually asking, we need to be at the table, nothing about us without us, because we understand how things happen in the real world, not in the lab, right? And we also know that often our communities are treated as sacrifice zones, and that it's not as important what we're experiencing as someone else's profits. So this question about commodifying carbon and understanding benefits and burdens is really critical to any kind of project design, product design, and policy design. We need to have a more inclusive way of making those decisions, both at the policy level and at the product level. Joel has heard me say this before. You want to ask yourself, where is the justice molecule in the molecules you're making? It has to be embedded. It can't be an afterthought. I'm not a chemist, so I'm a political scientist by training, so y'all can figure out how to do that. But it means to me that concept of who bears the burden and minimizing harm and repairing the damage, those are the justice principles that need to be embedded at every step of the design process. And so for us, the circular economy is not, recirculating more carbon, more chemicals, and more toxics through the economy. It's actually moving beyond that to, a resilient economy that actually restores harm. And one of the things that this is, again, a tool that we've used to try to think through technologies like carbon capture and sequestration, where in California, because we have an existing oil infrastructure and refining infrastructure and pipeline, they thought, oh, well, this infrastructure is already there. This makes a great plan to do carbon capture and sequestration. Well, you know where that infrastructure exists? It exists where communities of color live, and it exists in some of the most polluted air basins in the country, in the Central Valley, right? Even in northern parts of Los Angeles, there, again, so if your solution keeps pushing the burden back onto the people who have been bearing the burden of climate change that are hit first and worst, then it's not a solution, right? And we also think decentralization is a really important element. New technology, what requires the least amount of materials taken from the earth, right? This idea that you can more extraction. We worked with a metal manufacturer. We were at an event and we were having lunch, and he's telling me, you're not like most environmentalists. And I'm like, well, you're not like most polluters I know. And I just want to repeat it. Stop commodifying carbon for no other reason than it's really important. I'm going to stop sharing. And so the conversation, he made a metal that met the really stringent lead standard in California, and it's used for municipal water systems as a connector. We went through a whole months-long process of doing a full life cycle assessment. The product was safer, less water effluent, less effluent in the air, minimized lead in the air. Great product from a life cycle point of view. Upcycled more material. We couldn't get it on the market, right? The same experience we've had transforming wet cleaning, dry cleaning, right? We have, for 20 years, I've worked on this issue, not full time, just on the side, because for some reason, it just struck me as we have a perfectly safe alternative in wet cleaning. And yet, from a regulatory standpoint, from a business standpoint, we're continuing to use things like perchloroethylene or green earth that aren't better for the environment, yet we can't seem to make it work. So after many years, we finally got the South Coast Air Quality Management District to create a fund for hyperlocal air quality improvements, and we'll be able to transform, actually pay owners of dry cleaning to switch from the perchloroethylene green earth to wet cleaning, which is a huge thing, right? In a low-income community, these are mom and pop stores, because we couldn't figure out the big just transition. We thought, let's focus on small businesses and build a groundswell of understanding that you can actually transform your industry, you can make money, and we can defend the thing that theoretically we love, which is small businesses. And what we ended up finding that it's not as simple as switching the technology. One of the things for those of you who are making apparel, change your care label to say not dry, wet cleaning. That could really save the industry and make it transform to wet cleaning. It's as simple as that, right? Little care labels. But we also found that this is an incredibly traumatized industry. Almost all of them are mom and pop, and almost all of them have someone who has died from a cancer that may be related, because we can't say for sure, causality, to the product that they were using for years. And yet we still are 20 years after the technology was developed. We can't get it on the market because the one that's backed by chemicals has more money and more power. And we're not taking into consideration, again, to go in and make that transformation, it requires more than just the technology. It's support for those small businesses. It's actually acknowledging that these families are deeply traumatized, right? We worked with one in particular. I mean, every time I think about the family and what happened when the father died, who was the head of the family and the business person, they barely hung on, right? And when we when we were able to switch over, it was too late. They were beyond, the help of just a new technology. And so it's much more complex than just the new technology. It's making sure that it gets on the market and that you're supporting those small businesses as they make those transitions. And I'm going to stop because I think I've gone over time.
Thanks, Martha. So next we have Patrick Foley, who, if anyone ever needs a really good facilitator of a session, Patrick is like the best facilitator ever.
Thanks, Joel. Appreciate that. And thanks so much again, Martha, for your presentation and for your work. It was really inspiring. We're going to shift gears just a little bit because I'm going to be talking about our company and what we do, how we develop new technology. I'm looking around the room, and I think I see a lot of familiar faces, but there's probably a lot of people that don't know who P2 is. And so maybe I'll offer a brief explanation and have kind of an illustrative example of how our technology looks like in the real world. So at a high level, P2 is a green chemistry company. We develop platform transformations for sustainable raw materials, biorenewable raw materials, things that we think are beautiful, abundant, sustainable. And these transformations are often new, and they require new reactor design, and they allow us access to new high-performing ingredients for the consumer space. So we make ingredients for things that we use every day, flavors, fragrances, cosmetics and personal care, and more and more we're moving into markets that include crop care and high-performance polymers and textiles. So now I'm looking for the slide advancer. There we are. So if you were to ask what makes our technology and our approach unique, I would pair the concepts of process intensification and green chemistry, because that's really core to everything we do. So I think people understand these concepts individually. I'll just briefly remark on them. But process intensification, I feel like it's the way that all manufacturing should be pursued into the future. We're just doing it today. It allows you access to better heat transfer, better mass transfer, which results in better yields, lower energy inputs, higher safety. It also allows you access to modularity, so you can scale with transformational economics and agility. And this also allows you to do chemistry that you couldn't otherwise do because of the high degree of process control. And we pair this approach with green chemistry, which I'm not going to belabor the virtues of green chemistry to this particular audience, but I will say that it is really core to who we are and what we do, because we were founded at the Center for Green Chemistry and Green Engineering at Yale. Paul Anastas is a co-founder of the company. It's what the consumer wants, it's what the market wants, it's what the world needs. We're very motivated by green chemistry, and it's core to everything we do. A lot of our efforts are in the cosmetics and personal care space. We've scaled up a number of process technologies, but I'm just going to focus on one that I think is relevant for the conversation here today to kind of give you an idea as to what it looks like in practice and where we're at as a company. So the technology I'll showcase here is what we call PIOS, which is an acronym for Process Intensified Ozonolysis. It's essentially a way of harnessing a really strong and powerful oxidation in nature. Ozonolysis takes place all over the atmosphere. It reacts with organic molecules to give rise to natural products in very selective and very unique ways. And we've admired this chemistry for decades in the groups that I've worked with. And one of the problems with it always was that it was difficult to scale. But with the PIOS approach, we've been able to take this chemistry, harness it in a structured reactor that's 100% process intensified. So we can take things like renewable oils, electricity, and air, and have them converted nearly instantaneously into highly desirable functional molecules. The conditions for this transformation are very mild: ambient temperature, ambient pressure, and it's a very fast reaction, as I'll highlight. And I actually was looking at our utility the other day, and I saw that our electricity, which I knew was we were sourcing from renewable resources, we actually source it from Texas wind. So if you think about it being from renewable oils, wind, and air, it's really quite a remarkable transformation. But I don't want to minimize how simple the transformation is, because ozonolysis is a demanding chemistry, and that's why it has been tricky to scale over the years. Ozone is a very strong oxidant. It's a diffusion-limited reaction, so it happens extraordinarily fast. And it's very exothermic, so two carbon-carbon bonds are broken instantaneously. And so the way we've handled this with using process intensification is to take a thin film fast contact reactor concept, 1-inch tubes that are in a bundle, and we can have the film basically sitting in a cooling jacket that is modeled closely after a shell and tube heat exchanger. So we have very small amounts of liquid in the reaction at any given time, moving very fast through the reactor on, an ideal heat removal surface, so we can get very, very good process control, very high yields, and we can dose stoichiometrically. And to give you a sense for how process intensified this reaction is, the liquid's in the reactor for less than a minute, the gas is in the reactor for less than a second, and everything comes out of the reactor fully converted. From when we generate the ozone to when we return it back to air through a catalytic oxidizer, it's about 2 seconds. So we generate it on site, and then it's returned back to air. We just use ambient air to generate it, and for this reason, we feel like it's really a remarkable transformation given the comparable technologies to affect similar transformations. This is what the plant looks like, just with a couple pictures for show and tell. If you open that top tube on the left, you'd see that there's a 19-tube bundle that looks like a honeycomb, about 1-inch tubes. They are long tubes. They're 6 meters long, so to stand it up, it's about 4 stories. But its overall aerial footprint is still very small. And to scale up beyond this, you just add tubes in parallel, whether in the same bundle or parallel bundles, and the downstream processing is really quite straightforward. So as I mentioned, we're making things like flavors and fragrances and crop care intermediates using this technology. But the biggest opportunity by far for this technology is to make biorenewable intermediates for textiles and performance polymers, to make things like biorenewable nylon and polyester. And in this regard, we've scaled up with ADM to work with them on the feedstocks that they were backwards integrated into, high oleic feedstocks. We just recently completed our piloting phase, which went really well, and we're now scaling up commercial quantities for partners in the industry through 2025, and looking to make a 10 to 20,000 ton per year plant in the 26 to 28 timeframe. This is an exciting project for us. It's a big deal for us to find such a strong partner, motivated. And so if anybody's interested in learning more or participating in it, it'd be wonderful to talk about it. Also, I'd offer that we do a lot of other stuff as well. So if you're interested in learning more about P2, please don't hesitate to reach out to me. And I just want to thank the organizers again for including me.
Thanks, Patrick. And it's P2 Science is an amazing company, and what I'll say is P2 Science, along with I think Paxmer, Amit, Paul is here as well, our two first startups in our startup cohort, which we started that whole startup network here in 2015, or at least the first discussions leading up to it. So, and you've been a great mentor to a lot of other early stage companies, so appreciate that. So Renee, I'll leave the clicker for you this time.
Thank you. Thank you. All right, so Renee Hackenmiller-Paradis, I lead chemicals management at Lululemon. I'm also wearing a couple other hats while I'm here, since I'm going to be mentioning them later. I'm bring them up, full disclosure. So I'm also on the board of ZDHC, Zero Discharge of Hazardous Chemicals. Scott Eccles is also here from ZDHC, so if you have any tough questions about ZDHC, direct them to Scott. And then, as Bill mentioned in his keynote address, his wonderful keynote, I'm also on the advisory board for the Safer Chemistry Impact Fund. Again, direct questions to Bill or Art or Stacy for that. But anyway, many hats, but representing the brand perspective here. Excited to be back here at Nike. I haven't been on campus since about September of last year when I transitioned to Lululemon. And as Joel mentioned, I believe I was at the first GC3 at the time, Change Chemistry meeting that was hosted at Nike. At the time, I was the Environmental Health Director for Oregon Environmental Council, who I also saw they have some pamphlets out in front, so great organizations, great state-based organization. And I believe I was here trying to lobby John Fraser, who was also here, who was at Nike at the time, to support OEC's Green Chemistry Executive Order. He might not remember that, but that was my intent for being here. So anyway, feels like I've come full circle. Enough about me and my background. I want to spend some time talking, giving some brand perspective on this. And I'm just really going to talk about some examples of some challenges we see from our perspective and some solutions, and hopefully this will spur conversations or set off some sparks about some conversations I know we're going to have later about this. So, in this space so I do really focus on better chemistry, safer chemistry, and as a sustainability pillar. And in this, from the brand side, one of the challenges we have is phasing out unwanted chemistry for a number of reasons, right? One, we don't always know what's unwanted, and we'll talk about that in one of the solutions. We have regulation that tells us that's unwanted sometimes, but really we would like to be able to prioritize what is most hazardous. And I'll be honest though, we have to spend more of our time focusing on what's being regulated. Those sometimes overlap, and a lot of times they do, but not always. So figuring out how we can prioritize what's most hazardous and getting those out of our systems. As Laura from Patagonia mentioned, it takes us a while to do that, even when we really, really want to, because our product development cycles are multiple years and our supply chains are very big. Not saying that's an excuse, it is just a fact though. It takes us some time to do that kind of work. And then we're also very challenged by things like de minimis contaminant levels. PFAS is a great example of that. With the PFAS phase outs, we can remove it from our durable water repellents when we specifically had asked it to be in there. It's in our incoming water sometimes, right? And so how do we deal with that at the factories? Again, not an excuse, but I will say when we're looking at PFAS now, we are finding it places that we weren't expecting. which I guess we should have expected because it's a forever chemical, but that brings some challenges too, and that phase out of unwanted chemistry. Other challenges, avoiding regrettable substitutions. That again is, I think all of the brands have probably done this. Most of us did the C8 to C6 transition for PFAS. That was a real winner, yeah. Now we've realized that we shouldn't be using any PFAS and are working on that. But I think a lot of us did that long chain to C6 transition. And then we've also seen it with things like the transition from BPA to BPS. And it won't be the last one. So again, this is one of those where we really need better information about what is better and the availability of that better at scale to help us with that. And then this one might be, I've had some experiences with this lately that, and this one directly links to this topic. Low impact materials focus with unknown or unattended trade-offs. So a focus on carbon, low energy, and not looking at water use or chemical use. In particular, the chemical use is the one that gets me. A plant-based leather coated with a DMF-based polyurethane. That's one of those that just it's a head scratcher. Like, why would you go and spend all this time doing that and then coat it in this dimethylformide coated polyurethane? Another one that's probably less understood, but I'll just use it like things like a natural dye, which doesn't have the same level of color fastness, and then it leads to that product not being used as long, and so it doesn't have the longevity of a different product. So those are just two examples of some different trade-offs in the low impact materials focus. So solutions. These are just my ideas, so don't take them as sacred, but and hopefully spark some conversation. The first is a restricted substance list. I know most people have those, but that is the foundation. And not just a restricted substances list at the brands, but at the suppliers too, and having alignment between those. I've found in my time that Nike and Lulu and Adidas, we all have a common RSL, which we follow, and we have suppliers that say, oh yes, we have an RSL too, but they don't match. And so that creates some challenges for us. But a good RSL is really the foundation. Today I'm just guesstimating, but I would say the majority of our efforts are focused on that RSL output management. The RSL is really diagnosing a problem though. It isn't the problem, it's diagnosing an upstream problem. And so how do we take what we're doing and really focus more upstream on the input? First thing would be the MRSL, a manufacturing restricted substances list. So ZDHC has one that they've developed for the textile and apparel and footwear industry, and that's really qualifying what we're bringing into the facilities and making sure those meet our criteria, don't have hazardous chemicals. Next would be third-party certifications, which can, Okotex, Blue Sign are two examples of those, which can give you that, that chemical is MRSL conformant and more. So those are really good tools to use, especially if you've got fewer resources to invest heavily in RSL, MRSL. Next, actually 4 and 5 are kind of interchangeable, I would say. Chemical hazard assessments, screen chemistry, green screen. I have Stacy here from Chem Forward. I know we have Tox Services here that they do screen chemistry and Tox FMD, and then green screen. You can't do that without information though, so you need the chemical use disclosure and transparency. And we're working on that. Safer Chemistry Impact Fund is one of the groups that's trying to get after that, and the other groups I mentioned. And then lastly, kind of the holy grail of what we'd like to get to is sustainability writ large, assessed holistically and used for decisions. So the ability to look at what is the carbon impact of that material and that process? What is the water use? What is the chemistry use? How does it do for circularity? How is it going to be used at the end of life? ZDHC is actually working on an assessment type tool for that, for chemistry. We partnered with Blue Sign, and a lot of the chemical suppliers have gifted us ZDHC. I'm now wearing the ZDHC hat. A tool which allows us to look at and assess at those different levels. So then you can make informed trade-offs. There's always probably going to be some trade-off, right? There's going to be an impact somewhere. Using, making, buying, selling, transporting products, there's going to be an impact. But if we understand what those impacts are, then we can mitigate and make better choices about what we're doing in the end. So these are all just food for thought. Hopefully it spurs some conversations, and look forward to the discussion.
Well, I'm going to start. Here's a mic for you all to use. I'm just going to start with a couple questions. We'll take some questions from you, and then we're going to do some homework at the tables, get you talking before lunch for a little bit. So I'm going to ask you, Renee, first a question, because I know Lulu's doing some really amazing and game-changing work in nylon 6 with Genomatica, and actually this came up. I was at a chemical industry conference last week, and everyone kept referring to Lulu yoga pants, the model, right? I heard the term, the niches are the riches are in the niches. So can you take something that's a high-value product, show proof of concept? So how are you working with your R&D teams that are working on biorenewable materials and decarbonization to make sure that the lens you bring gets into what they're doing?
Yeah, thank you for that question. So just so those who don't know, Genomatic does make bio-based nylon 6/6, which is the bread and butter of our lovely Align yoga pants. And Lululemon actually made a very significant investment in Genomatic to help them be able to get to scale. So how my team works with the innovation teams that drive this, the innovation teams are fully bought in on better chemistry, and they tell any potential supplier that they're working with that first you have to take this by Renee's team and make sure that it meets their standards. And we're not just looking at the product that comes out, but we're looking at the chemicals they put in and the processes to make sure that it, at a minimum, is not doing more harm than the original, and then hopefully better. I will say we need more tools to be able to determine, is that better? And because you can't just look at one point in time to see if something is better. You have to track that, you have to track the waste and all of that through, which ends up where it's going. But we've got a great partnership with our innovation teams that have laid down that line that said any new low impact material product process we bring also has to be using better chemistry.
Great.
So.
Thanks. Patrick, I think one of the things you raised in talking about process intensification, John yesterday said, we haven't actually made the molecules yet. We need to do so much more molecule making. I mean, do you see the problem as really coming up with the processes or scaling the processes to make these innovations, or is it a combination of both molecule innovation and the processes to actually make things more effectively?
It's a big question, and lots of thoughts going through my mind, but I guess one way to answer that question is just to say that if you're just relying on existing reactor design and existing capabilities, you're going to be hamstrung by a different paradigm of thought and a different toolkit. And so if you want to do something new, you really do have to think of how to accomplish that with all of the criteria that John laid out. How are you going to do it so it scales? How is it going to do? You're going to do it so it's cost competitive? How are you going to do it so it's not backwards integrated into a petrochemical feedstock? And in order to do all of those things and to accomplish them, you do have process intensification lends itself really well, but you have to have it in mind from day one.
Great, thank you. Richard, you had mentioned in your talk stranded assets, and we've certainly heard that is a huge barrier to companies transitioning out of their current sort of feedstocks and feedstock chemicals. I mean, where does Planet Tracker see this issue of stranded assets as both a risk and an opportunity, and how do you sort of bridge that?
Thanks. Yeah, I think the risk is obviously if you've got an asset that you're building, let's say you're even building it today and it's on legacy chemistry, is that really a sensible investment at this point? Can't we all see the direction is going? It's got to be something that is going to be able to put in alternatives that are less toxic and less oil and gas based feedstocks, for instance. So I think from a risk perspective, it's the technology that you're backing. Is it really future proof and therefore competitive as regulation changes, consumer demand changes? The opportunity is obviously sort of the counter to that, which is that if you're the innovator, if you're the market leader, you can win market share by offering innovative chemistry. We heard it today. You know, I've never heard of the process of what was it, oxyonylis? Oh, sorry, I'm going to completely butcher it. You know, that sort of innovation is really exciting because it brings something that that isn't being done yet, and can be scaled. So I think the opportunity is really around making sure you're future-proof with your assets rather than locked into legacy technology.
Great, thank you. And Martha, I love the term justice molecules. So how can an innovator in the green chemistry space engage better with impacted communities to understand what these trade-offs might be and really truly build justice molecules that solve multiple challenges and can make it in the marketplace too?
Well, you know, I think there's a number of ways. One, I'm reminded, and I think you might have helped me on this project. We were working with domestic workers who had been we worked on a bill to ensure that cleaning products were labeled. And through that, we connected with the National Domestic Worker Alliance. And they were they wanted to shift how people were doing cleaning. And they were coming, you know, they wanted, from a worker's perspective, they wanted a product that they could use as workers that's not being just used once a week, you know, the way normal cleaning products are meant to be used, right? And we would often hear, well, you're not using it as directed. No, but as a domestic worker, they don't have a choice, right? So the idea was to create a line of products that were safe to use and that the domestic workers could market. And now we know there's better preservatives, but at the time there were no, you know, stabilizers or preservatives that would work that would meet their standard. And so I think that you connected with folks who are working on that to solve that problem. I think that's one. And the other, you know, much the same way that wet cleaning emerged, right? Dry cleaners are saying the owners are saying there has to be a better way than this. So starting from the end user and thinking about the community where it will be produced and where it will end up. What does the circularity look like? Is the circularity sort of a way of maintaining the toxicity if it's not designed right? Products that, you know, when we look at the cumulative impacts of pollution, we started to identify metal manufacturers, dry cleaners, and auto body shops as, you know, aside from the major sources of traffic and goods movement and those kinds of things, in many low-income communities, these were overrepresented. So we wanted to focus on those industries and move from there to figure out what are those solutions. So that may not be the most profitable approach, but it is about using green chemistry to solve the problems that old chemistry has created in terms of what people are breathing and what's in their water and what's in their soil.
Great, thank you. Let's take 5-10 minutes for questions from all of you, and then we'll have homework at the tables.
Hi, everyone. Thank you for a great panel. And this question is for Richard. Richard, this is Allie. Great to see you, and thanks for joining us late. There's a lot of focus on the costs and risks of transitioning to safer chemistries, but as Planet Tracker has shown, in your research, there's enormous costs to maintaining the status quo for investors. For example, Bayer has lost 70% of its shareholder value since the acquisition of Monsanto, where they took on the liability from glyphosate, a known carcinogen used in Roundup. So my question to you is, how can investors better price this risk so that we can really take that into account when we think about financing the transition to safer chemistry? Thanks.
Thanks. Yeah, that's a great question. I think the first part of the answer has to be transparency. I think they need a lot better information on what the companies they're investing in are making, where they're making it, processes they're using even, because sometimes, you know, intermediate chemicals can be a big concern. So I think that's a huge part of it. And then it comes back to science. I mean, there's some scary numbers out there about, I think it's around 16,000 chemicals that go into plastics, of which only a very small, well, not very small, but about less than half have been tested for sort of human and environmental toxicity, and a huge amount of those were shown to be toxic. But if you haven't tested a chemical, how can you possibly price the risk of it potentially being, you know, a terrible carcinogen that you're going to end up paying out huge amounts of money for? So I think transparency, research, and precautionary principle. If you don't know the answer as an investor, then be concerned. Start to think about what, you know, sort of risk numbers you're thinking about for this corporate. If they're not willing to share with you what they're doing, how they're doing it, more information, even, you know, confidentially, then there's maybe the skeletons in the closet you need to start worrying about. So yeah, I'd call for better transparency as the absolute first stage in allowing a better pricing of risk, and that will then drive more sustainable chemistry, because when we know risk, those who are most risky have the highest cost, and that will drive us towards more green and more sustainable chemistry in the long run.
Yep.
Yeah, so Jennifer Foreman, I'm with ExxonMobil. I have a question. So sometimes the biggest challenge for innovation can be regulatory uncertainty and how you define certain aspects. So like I keep hearing toxic free, no hazard, but whenever you look at EU legislation, you have to test substances until they cause a hazard, otherwise the test is considered not appropriate. So it's kind of like the regulatory environment requires testing. And even the comment on glyphosate, like IARC says it's a carcinogen, but EPA says it's not a carcinogen. So when you say known carcinogen, there's also different in opinion. So how do you kind of crack the regulatory certainty nut? Because if you don't have certainty, like you do something like Bayer where they invest in Monsanto because EPA said it wasn't a carcinogen, so they said, okay, we're going to be good, but then found out no. And that caused major problems for them. And so you have a lot of, it creates a lot of challenges whenever you're trying to innovate, and where do you invest your money and spend your time?
And I start
I'll
with you,
take
Renee,
that,
and then
yeah.
maybe Richard, you could talk about that from the investment perspective, where there's differing opinions, and how do you sort of weed through that?
Yeah, so I would say from my perspective, I mentioned the chemical hazard assessments. That's not a perfect answer, but we treat lack of data the same as a carcinogen. So on a toxicology assessment, if you're looking across at all your endpoints, something that's a carcinogen, no. If there's a data gap and we don't know, we treat that the same as a carcinogen. So it's not a perfect answer, but I would actually prefer to use something that I know has some toxicological endpoint that I'm not happy with, because I can mitigate that. I can, I say me, but you can control that, right? You can make sure that it's not used in certain situations, or proper PPE is used if it's a skin sensitizer, things like that. The lack of data, though, that puts you in it could be anything. Like it could be plutonium for all you know, right? So that's how we try to address it. It's not perfect, but that's one of the ways that we approach it.
Richard, do you want to add in, how do you think about that from an investment perspective, where something is considered maybe okay today, but not tomorrow?
Yeah, I mean, I think it's really difficult. And I mean, even something might be considered okay in the US and not okay in Europe, and vice versa. I mean, we see this difference. I'm doing a project at the moment comparing, the US regulation to the EU regulation. And it's really interesting to see how the risk and the hazard approach differs in the two different jurisdictions. So I'd always say the precautionary principle: put the data out there, be cautious, make sure it's available to communities that are exposed, and then they can have an impact. At the end, it becomes almost like a science and a politics decision as to what way you deal with regulation of these chemicals. But without transparency, without data, investors, communities, scientists, corporates, no one knows exactly the best way to approach it. So we need better data, and then we can all have the conversation.
Yeah. Patrick, let me ask you a follow-on on that. I mean, I think that for newer stuff, it becomes a little bit easier to fail fast, I assume, to just sort of poke holes and say, yeah, this isn't going the right direction? Or how do you think about it at P2 Sciences?
Yeah, so at P2, we do have the advantage of being able to do everything from the ground level, from day one, systems up. And so we understand the toxicology profile quite well, and we understand the global regulatory framework. And so we have a theory of the case as to how we're going to navigate it from the very beginning. And it requires a lot of testing, and it requires both standard testing for, OECD testing, plus everything that every multinational wants to see, which is often an even higher bar in terms of safety testing. And so you go through all of that, and obviously you have to take all the results seriously, but you're optimistic that you'll get favorable results and be able to navigate the tox side of things, and you kind of understand how it lines up with the global regulatory. That said, there are intractable problems with the global regulatory for I think everybody here is familiar with some of the challenges in the cosmetics personal care space. You can't test on animals, but there's regulatory bodies that require testing on animals for new chemistries. I'm thinking China in particular. And so, which is a major market. Sometimes it's upwards of 30 or 40% of the customer base for some of the multinationals. And I mean, that's just an intractable problem, and you have to be able to come up with a strategy to manage that and communicate that to your partners. And, we haven't figured it out. If anybody has cracked that nut, please let us know.
Let's take another question. Go ahead. Oh, there's a couple, so we'll take the two from that table.
Thank you. Lori Valeriano, Toxic Free Future. I appreciated the comments around certifications because it is a way to, find safer products. The challenge is that they're not all in alignment with what is safer, and they're not all hazard-based. And one of the things, our State Department of Ecology and Health, they do really great work to identify safer alternatives. And one of the ways that they can do it, because the lack of data or, CBI, is through saying, to aligning with the certifications, aligning the criteria to the definition of safer in Washington. But there's so few certifications that meet their definition of safer. So it's really green screen certifications, it's safer choice, and cradle to cradle gold. So my question, and then, the good part is that they identify safer alternatives, and then they create subsidy programs that then support businesses in the transition. So from BPA and BPS receipts to Pergafast, or whatever it's called, paying them to do that. So my question is twofold. One is, how do we get those certifications in alignment so there's more certifications? And then, is it helpful to create those subsidies at the state level that because it's expensive to do certifications, is it helpful to make more of those happen? Just your thoughts on that.
Yeah, and I agree with you on the certifications. They kind of run the gamut. When I was mentioning it, I think they're a good proxy for RSL compliance for especially like a smaller business or someone who doesn't have the resources. I think it's continuing to let them know too, though, like brands and NGOs and others in between saying this is the gold standard, and putting those gold standards up there, and then it's competitive marketplace, right? And who gets there? As far as the subsidies, was it subsidies to transition? Is that how it? I love that idea. I think that's like actually I know from some work Nike did with phasing out of BPS receipts, the going to Pergafast. There can be some cost differentials there, right? Or even just understanding where and how you get it and the testing validation you need to do. Because with any phase out or transition, the unknown costs are like the testing. Is that Pergafast tape going to work in our handheld printers and things like that? And however that can be incentivized, I personally, not from a Lulu perspective, but personally, I think that's great. So does that answer your question? Yes, thanks.
Yeah, and I think we heard from Marta, right, that support for the transition of the dry cleaners was really key. We saw that in Massachusetts too, giving $10,000 to $30,000 grants to dry cleaners to transition makes it happen, right? It shows proofs of concept. It allows it to happen where there is a cost to buying new equipment.
Yeah, we do that in Washington too, and there was a massive shift to wet cleaning over the fossil-based alternative.
Good. We'll take one more question, and then you want to pass your mic.
Thank you. I wanted to ask Patrick, that's the second time I see you presenting. The first time I saw your presentation was at Yale University.
Oh, very good.
Yeah, and we had some training, and I remember.
I remember well, yeah.
Yeah, you were one of the speakers, I believe, in that training. And my question is technical. I really appreciate this idea of using ozonolysis, highly selective for double bonds, to create new chemistries and this new design of a reactor, new way of thinking. If you can elaborate and a little bit talk about the selectivity, like how do you prevent the formation of peroxides, and how do you stop the oxidation and control the oxidation reaction? For example, if you want to generate aldehydes, how do you prevent the formation of carboxylic acids? Is it via specific catalytic systems that you use, so it's more of a rates and temperatures? So what is in toolkit that helps you to be selective?
Well, thank you for your question. I love that you're asking a super technical question. I apologize to everybody else in the room that doesn't want to hear me talk about organic mechanism, but I love it. So the ozone molecule does react exquisitely selectively with double bonds. And so orders of magnitude more selective than it would be for a different functionality, even something that's easily oxidizable like an aldehyde, for example. And I mentioned that we can stoichiometrically dose, so near stoichiometrically, so it's very close to parity, so we're not having excess in there, and the reaction times are very, very fast. So in the reactor for less than a minute, it does generate the peroxide, and we quench it as it comes out of the reactor. And so that the ability to control the time and the stoichiometry allows you to prevent over-oxidation and oxidation of other functional groups. So it's much higher yielding than the traditional processes that have been deployed at various scales. With regard to the, what was the follow-up question? Well, there was a second component to your question. Sorry, it's escaping me, but
Aldehydes to acids.
oh, yeah.
You answered that.
Downstream processing. So yeah, once you quench, then you have optionality, right? So once it's a peroxide-free system, we call that passivated. Once it's passivated, then you can take it in any direction that you want. You can go to the alcohol, the acid, or maintain the aldehyde. I'm sure you can appreciate, the aldehydes and the ketones are very prized in the F&F industry, so we've developed a lot of techniques, some proprietary techniques using very inexpensive organic quenching reagents, so we don't have to use things like sulfur or phosphine, and which also cause problems in the F&F space because trace amounts of those result in off odor. And so we have really elevated the downstream processing as well as the reactor technology itself.
Yeah, thank you.
I'll try to, I'm not going to translate it well to English, but I think the question related to, and you should correct me, of even natural processes, if they're reactive, can actually, and not well controlled, can actually have unintended consequences that could be problematic.
For sure. I think in this particular case, when you have an oil and an oxidant, you're dealing with a pretty safe kind of, I guess, combinatorial chemistry space of possibilities, a matrix of possibilities. And so it's inherently safer than so many other different paradigms, right, when you're using various types of solvents and halogenated reagents and heavy metals and things like that. But even within this system, it's very highly selective.
Yeah. Good. Okay, if we could throw up the questions, we're going to take a few minutes, and Richard and Martha, we're going to come back to you to close out. What we want you to do is think about at your tables. Just start a conversation at your tables, right? We've had this conversation about the needs, right? We're trying to move away from fossil fuel-based chemistries. We'll need carbon to make chemistry, right? We're going to be making stuff. What are we going to make that stuff out of? How do we do that in a way that addresses both, carbon and toxicity? What are we learning from this? How do we do this better? And I think there's a question in there as well about what are some of the concerns we have about that. We heard about regrettable substitutes and false solutions. How do we sort of put those on the table and say, what's the directionality, knowing that we heard the time frame here is long. So how do we make slow but sure progress towards better understanding, you know, these potential trade-offs and trying to address them up front. So take a few minutes, talk about these questions, and how do we address these? Identify them and address them early on. So take a few minutes at your tables, introduce yourselves, and think about how do we co-optimize the two. Okay, we're going to get Renee and Patrick back up here, and if we can get Marta and Richard back. So if we can get the Zoom folks back, we got Richard. Hopefully we didn't lose Marta as well. Okay, good, we got Marta too. So we're going to wrap up here, but anything that sort of quick reflections, anything stand out like, I never thought about that, or a new challenge, a new opportunity? People are like, we want to go to lunch.
Hey, this is Akash Kokai from Apple. Just a really naive suggestion to throw out there, and I'd like people to just push back on it, but what if for every chemical product that's sold, we could have a full chemical hazard assessment and a life cycle assessment? And then just have that be part of the value chain.
Okay.
I mean, I think there would still probably be like a miss on like community impacts assessment and things like that. But hey, I don't know, just a suggestion. Thank you.
Thanks for the challenge.
Yeah.
Any other big thoughts or takeaways that people had from their discussions? Quiet group. Okay.
Everyone's hungry.
Well, we'll continue the discussion over lunch. Let me just ask, we'll start with Marta. You just final reflections on takeaways, people from the other presenters you heard. You didn't hear the discussion, obviously, but takeaways that this group should come of innovators that really want to drive better chemistry forward.
Oh boy, so I would issue an invitation to actually work directly with environmental justice organizations and begin to root your new and innovations in solving long-term problems of hazardous waste, right? In Los Angeles, we can't build more housing. There's a lot of community benefiting things that we can't do because of all the soil contamination, no responsible parties. Where are the innovations in cleaning soil that don't create hazardous waste that we're not going to dig and burn and haul? So really thinking about end of life and cleaning up that mess and not necessarily commodifying it to make it waste that goes into another community. So I think those to me are the big spaces for innovation to clean up the mess we've already made in a way that's safe.
Great, thank you. Richard.
I mean, I think I'd just echo the transparency. I thought the last point from the floor there, why can't we have LCAs and toxicology data for all these chemicals we're using? I mean, it's not beyond, we can get men on the moon, try and get them to Mars, when we can do this.
Great, thank you. I appreciate that big picture. If we can get someone onto Mars, we can figure out the toxicity and the life cycle implications of chemistry. Patrick.
Yeah, I just, is this on? Yeah. Offer that. I hear you, Martha, and you were very compelling. We should not commoditize carbon.
And Renee.
Actually, and I was going to thank Martha too. All of us on the panel, but Martha, I really appreciate you reminding us and bringing that perspective of impacted communities, because I say this when I'm talking to friends about, they hear about the latest toxic chemical in, certain products, and at the end of the day, like I believe like our products are safe for the consumers. We can discuss that in more detail later, but I believe that. Where I think there is a lot of opportunity is the makers who are making our products and where those chemicals are coming from, to Martha's point. And I'm actually really energized by this conversation. I feel like I've been pushing a rock up a really steep hill for 20 years now. Lori and I were reminiscing last time we'd been together. And I feel like we are at a tipping point where we've got a lot of the right players in the room, and we have access to the information. We just need to figure out how to make it happen, and then use that information to make informed, good decisions for the planet and the people. So.
Right. And as we know, I think as you've raised Renee and the whole John Fraser 15 years ago when ZDHC was being formed in the detox campaign, like reputational risk to brands really does matter, and it does force you to go upstream and say, holy mackerel, we weren't thinking about this. So very good. Well, thank you, everyone. An amazing panelist. Thank the panelists. And you know, I think we'll keep hearing, you know, if this were easy, we'd be doing it already. So this is not easy stuff. We're trying to solve a lot of problems at the same time. And I think the open discussion, the willingness to challenge each other, the willingness to think outside the box is really critical as we try to build, you know, the scalability of green chemistry. So now we're going to have lunch. Lunch will be out there. It is Taco Tuesday, but no margaritas yet. I don't know whether there's any margaritas later either, but we'll come back here, and in the next panel, we're going to start talking about how do we finance and drive the incentives to grow the better at scale. So have lunch, network, connect, and we'll see you in a little bit. So at 1 o'clock back here.